Good afternoon, sir.
Yes, shall we start?
Yes, sir.
Right, okay. என்ன பாட்டெல்லாம் கேட்டுக்கொண்டுதான் கிளாஸ் போலாடாக்கா?
இல்ல சார், பக்கத்துல கோயிலாங்க ஒரே பாடம் சார்.
ஒரே பக்திமயம் தான். Yes, good. Right, we have left with today we will learn only two analysis, that is nested design and the split plot design. Usually some of the agronomy people, I have seen people doing a lot of research in the design of a split plot design, so that I will cover the split plot design also, how to do it using SAS. Right? Not only agronomy, other people also can do it on split plot, but very rarely you come up with split plot in other fields other than agronomy, right? Right. But that doesn't mean other disciplines cannot apply split plot, because, for example, if you are introducing a new treatment after establishment of the experiment, then we can apply the split plot concept. Right, hope all of you have, we are going to work with the two sets of data that we have given in the class, that we have discussed in the class, nested design and the split plot. Right, I have already saved those data in SAS, so that I will click directly. The first one is I will go for the nested design, right, which we have done in the class. We have already talked about this in the class, right? The sums of square, degrees of freedom, the mean square, and the testing. Right, there are slight difference here in the split plot and the nested design. What is the difference in the ANOVA and the testing compared to the other designs in nested and split plot? There's a small difference at the end of testing. What is the difference? Anyone? Maybe it is true with the split plot or true with the nested design. Anyone? What is the difference?
Calculated value.
Yes, calculated value. Yes, of what?
For the main effect, we want to divide it by main effect.
Exactly. So here, when you want to go for testing, we are using different errors, especially. We are using different errors, if you can remember, nested design and the split plot design. Whereas in the other designs, we never use two different denominator for looking at the effects. Looking at the effects, we have used the same component, which is the error component. But in nested and the split plot, the error component is slightly different, for only on certain cases, right? For example, in nested, for the main effect or main factor, or the first factor, right? In the nested design, for the first factor, let's say factor A, factor B in the nested design. For factor A, the denominator to test whether there is an effect, the denominator is not taken as the normal error denominator. Normal error will not be considered as the denominator. Look at everyone, the notes. So how we can do it using SAS? Because by default, SAS dividing all the component by the error component. If so, how we can make the different statement or different program? Let's see that also here. Right, this is the example that we have discussed, if you can remember. Data, I will say nested, right? Then input. In our example, name all the inputs. What are the inputs? This we have done in the class. I have discussed this in the class. I gave you as a homework on the following day. We did this. Explain this. What is the first component, second component, third component, and the fourth component? How it is in order? Vaishnavi, what is the order?
Area,
Area, yes.
size,
Site,
replicate,
replicate. I'll put it as well. The last one, let's say it's a value, right? I will consider it as value. Area, site, replicate, and the value. Then we have the cards as usual. Then we have the data. I hope everybody could have entered the data because I told you no, to enter the data. Anyone has problem in entering data? Indujalini, have you entered the data in your computer?
Yes, sir.
Right, so you'll have to do it by yourself. Huh? Then only people who have SAS, you'll have to do it by yourself. Then only you can. Because already I instructed you enter the data accordingly before we do the analysis. So that is easy for us. Otherwise, it takes about half an hour to enter the data. Right. Is it okay with the first information? Initial introduction information, data, input statement, cards. Then we can take right a semicolon. Then what is next? Proc Anova. Now you will have to recall the models and Proc Anova fine. What is the class? Here also classified variable. Indriyalini, tell me what is the class? What are the class? Classified variable.
Size,
Before site,
area,
area,
size,
site,
and replicate.
replicate. Okay, good. Right. Now, something wrong with the, otherwise it will show colors. Yes, I have. Can you notice some problem in my typing?
The symbol.
Huh? I didn't hear anything.
So that symbol, Proc Anova, the latest.
Yeah, you can put this symbol and try. It will not run the program because I identified because after the Proc Anova you have the class variable. Normally it should give a blue color. If it is not giving in blue color, something wrong. So that is the problem. You see, now I change into semicolon. It's give a blue color indicating now you are writing correctly. Right? If you could observe, now you see class is in blue color. So that means you are in the correct pathway, correct step. Right? Model. Now that model should reflect our model. Can you tell me what are the components in the model? Here, how many factors are involved in this nested design? How many factors are involved in this design? Anyone?
3 factors.
Actually, how many factors? How many factors? Anyone?
2
Four
Two
factor.
Two factors, yes, two factors. What are the factors? First factor is area.
Area and site.
Second factor is site. So two factors involved here. But another side we have replicate. That is fine. Replicate is not a factor, right? So how we can write down the model? Definitely the y variable, which is value here, I will put it as VAL, is equal. Anyone? How we can write based on, look at your model, look at your ANOVA, and tell me how we can write the model. This is in a normal setup. Right, tell me. If you can remember the model, tell me the model. Y, I, J, K. How we can write down the model? Two-factor nested model. Anyone? Mu plus, let's say alpha I plus look at the notes and tell me.
Beta Ji.
Beta
J
J,
nested into I bracket
yeah,
EKJI.
right. Right. So this is the model. Now here we don't need to enter. Here we don't need to enter. We will have to enter this value, this value, this value. Now tell me how we can enter these values. Kirija, how can you enter these values? Tell me. I have already entered the first value, right? I have entered the first value as value. What is the second? What is alpha I? It is the
Area.
area. What about beta J?
Site nested into area.
Site. So I can write it as site. Look at everyone very carefully. Within what? Site is within what?
Area.
Area. So I will put it as AREA. Very carefully look at it. Model, you cannot simply write site. If you simply write, it will give some other types of sum system. So site within the area, then only computer will calculate. So those are the only components that we need to write. Everyone clear? We are going to run. We are going to run the program. Have you all written down the program? Everyone? Write down the program. Everybody should know what is the meaning of site within the area. Site is nested within the area. So that is why we are writing site within area. Once you say, okay, I can execute the program. Our leader is, where is our leader? Are you around? Ashraf?
Yes, sir, I am here.
Okay, okay. So can we run the program?
Yes, yes, sir.
Okay, right. I will run the program and see. This is the first step that we'll have to do. Right? Maybe the other steps I will show you. This is the first step. Right. In the first step, we have run the program. This is the primary information, area, site, and the replicate. Everything is fine. Total number of observation is there. This is the ANOVA table. ANOVA table is there. Now, if you look at the model, if you can remember the model, what are the components, right? The model is expanded into these two components. If you can remember, what is that? Area, site within the area. Area, site within the area. We are cross-checking with our answer. We are cross-checking with our answer that we have already done in our class, so that everyone, you know what we are doing, right? So we have the degrees of freedom 2 for area, degrees of freedom 9 for site within the area. Total degrees of freedom is 35, and the error degrees of freedom is 24. So that is fine. So this is equal to this 11 degrees of freedom. Am I right? Yes, we have done already, so you can cross-check. Right, now, second part, their respective sums of square. Area and the site within the area. Now we can test two things. Only we will have to test area and site within the area. So we'll have to test these two. Not only one, we'll have to test these two. For area, for testing area, mean square of, I will put it as area divided by mean square of error. So that we have already tested, right? Computer has already given directly. You see the, I mean, what normally we say, we will come to that, the correction later on. So this is the normal procedure to calculate the F value. To calculate the F value for the site, mean square of, I will say, site divided by mean square of error. So that is what the computer has already done. So this value is actually this value. Divide this mean square of area, that is 2.25, divided by what is the mean square of error, that is 4.5. What is the answer? That is 0.5. So that is normally computer does. But can we accept this proportion? Can we accept this ratio of the F calculated value for area? Look at the second one. We are testing the site within the area. So mean square of site divided by mean square of error. That is the value here. That is equal 3.17. So that is equal, actually, what is the mean square of site within the area? 14.25 divided by 4.5. So that is 3.17. Can somebody tell me, can we accept these values? We have two calculated value, this value and this value. Which value we can accept at the moment? Area F calculated value or site F calculated value, according to our theory. Kirija?
Site calculate.
Site.
Site, we can accept, right? Site calculation is correct. The area calculation is wrong. Why? Because the error mean square should be something to be replaced by mean square of site within area. That has to be replaced by that. Unless we tell the computer replace this by this particular component, computer will not do that. by default, automatically, computer divide all the mean squares by the error mean square to test it. Right? Right. Everybody understood that. So now we can explain this. We will come to this area in little while, how to test that. We can test this null hypothesis beta j within bracket I is equal 0. That is my null hypothesis. Right? That we can test. That is where here the site within the area. So what is the p-value? P-value is 0.0116. If you take alpha value as 0.05, what can you say about the effect of site within the area? Anyone? Anushalini? Ravichandra, Anushalini, Ravichandra. I couldn't
P is
hear.
larger than alpha.
Yeah, P is
P is
which is larger?
larger than alpha.
Are you sure? Which is larger than alpha? இது பெருசு இதுல திருப்பி மேத்ஸ் படிக்கணும் போலடா.
Alpha larger than
Alpha larger than P. கண்ண முடியும்னு சொல்றேன். Alpha larger than P or P less than alpha. So what is our conclusion? Are we rejecting or accepting null hypothesis?
reject
Rejecting our null hypothesis. So because our alpha is higher than the p-value, so that we reject our null hypothesis. So our conclusion is there's a significant difference among the sites within the area. So we are comparing different sites within each area. So what is next? We'll have to do a mean separation, for example. Then we, for each area, because we said there is significant difference among sites within area. So this is my final conclusion. There's a significant difference among the sites within the area. So area, for example, I will take area 1, area 2. I will take only one area, sorry, 2 area. Let's say site 1, site 2, site 3, site 4. Here also, let's say we have site 4 site 5, site 6, and so on. Now, what I explain is, here, I am comparing only these sites within this area. I cannot cross and test with the other area. So within A1, I can test whether is there any difference between S1, S2, S3, S4. That's all. Within A2, I can test whether there's a difference between S5, S6, S7, S8. That is how we do it. That is how I explain here. So within the area, we are looking whether there's a difference in among the sites. So this is the result says there's a significant difference among the sites within the area. Then we'll have to do the mean separation for each area separately. Like, can you remember in factorial we talked about? If the factor to interaction is significant, then we do the mean separation, keeping one level of factor constant and compare the level of other factor. Right? Similarly, here also you keep A1 or constant, then you compare S1, S2, S3, S4. Then keep A2 constant. Compare S1, S5, S6, S7, S8. So that is how you go for the mean separation. Right? Now, how to get the second? Okay. Any question about this? This is about the site effect. Now, what about the area effect? Area effect, we cannot consider this calculated value because why? It is divided by the error term. Any questions? Because I'm going to erase this. Any questions? Now we are going to look at how to interpret the area. Any questions?
No, sir.
Okay, so this is the first interpretation, right? Now we have already interpreted our site because already it is significant. That is why I interpreted. For the area, we'll have to do a small different calculation. Right, now we will go for the new calculations for the area. I will go for the, again, the program. We'll have to add one more statement there. We'll have to add one more statement there. Test is a test. H equal, here write down, H mean, don't write it on the SAS program. H mean it is hypothesis. What is our hypothesis? What is the hypothesis that we want to test? Area. We want to test area. Automatically, it gives some information. Then is the space E, error term. Consider this as error term. E. What is the error term for testing area? Anyone? Kirija? What is the error term to test the area? I have already mentioned this. Yeah. Site. What is the component? Site within the area. That is the component, sorry, within the area. Right? Site within the area. Look at very carefully. I am giving an additional statement. Test H mean hypothesis. What is the hypothesis? It is equal area. And the E is equal, E mean the error, is equal site within the area. Okay. I'm going to run the program and see what is the output. In addition to the early output you will get it, right? Early output, you will get it as usual. Up to here, you get similar to the earlier one. This is a new one. So you see test of hypothesis using the mean square for the site within the area as an error term. You got it? So I'm testing area, right? I'm testing area as the mean square of area divided by mean square of site within area. So that is what it says, our error term. This is our error term to test the area. So now it is considering our error term as the site within the area. Read very carefully. So this is the additional information that we are getting. In this case, no problem because the values are very small, so that there will not be a problem. So that this is the mean square of trick and area, that is 2.25 is the mean square of area, right? What is the mean square of site within the area? Mean square of site within the area, what is that? This one, right? Am I right? 14.25. So what is the answer of this? This is actually 0.16. So that value is further small. You could see. So that is the value there. So what is the p-value? P-value is 0. What is the value? 8563. Alpha value, as you all know, 0.05. So we do not reject our null hypothesis because the alpha value is smaller than p-value. So do not reject H0. So in other terms, accept your null hypothesis. What is my null hypothesis here? Alpha I is equal to 0. So that means no difference among the area. So ultimately, my result is there's no significant difference between areas. So this is my conclusion. There's no significant difference between areas. On what will I tell? Maybe yield or value. There's no significant difference in yield among or between different areas. That is how we interpret it. So here we like to do the mean separation only for site. So site within each area. Yes. Site within each area. As usual, we'll have to do it like earlier one. Right? Proc sort by, for each area, you'll have to give the ANOVA. So that proc, before that, proc sort by area, then proc ANOVA by area, then classified and so on. Then you can simply take the model. Model is simply value equal site. So within area you can remove, because already we are putting ANOVA for each area separately. Right, any questions? So this is about nested design. Normally you rarely come up with nested design, except maybe some economics people. Economics people who are involving with questionnaire survey, farm visits, because each villages are nested, farmers are nested within villages. We cannot cross over the farmers. Kilnochi farmers not same as Vavuniya farmers. Sometimes we do the crossover comparison, but it is wrong. The facilities in Kilnochi is different from facilities in what do you call Vavuniya or Anuradhapura or whatever it is. Yeah, any questions? Any questions? All are silent.
No, sir.
No question, right? Okay, now I'm going to talk about split plot design, right? Split plot design, the same example that we took it in the class. I'm going to do it again. I have already entered the data, so I'm going to say data split plot. So I will simply say split, right? Input irrigation. I put IRR, nitrogen NI, block BLC, and the yield. So this is the example that we came across in our practical or theory class, right? So write down as such: data irrigation, I double nitrogen level. If you can remember, 0 nitrogen, 15%, 15 kilogram and 30 kilogram, if I can remember. What is the two types of irrigation?
Rain fed and irrigated.
Okay, rain fed and irrigation. What is one? What is one here under the irrigation?
Irrigated.
Irrigated. 2 mean it is rain fed. Nitrogen categorized into 1 mean 0 level of nitrogen, 2 mean 15 kilogram nitrogen, and 3 mean it is 30 kilogram nitrogen. Then block. How many blocks are there?
3 blocks.
3 blocks. Okay. Right. Now I will go further. Proc Anova, same kind of programming as we did it for nested design, right? Proc Anova. Then we go for class classified variable. Can somebody tell me what are the classified variable?
Block irrigation,
Okay, I will start with irrigation. Then
nitrogen,
nitrogen
block.
block. So here you see there's no need of putting the capital and simple. If you want to brush up beauty, keep the beautiness of the program, you can keep the capital, simple, and so on, right? Doesn't matter for computer to understand. Right. Model, you'll have to be careful about the model. Tell me what is the model? How many factors involved here? 2 factors, irrigation and nitrogen. So now somebody can tell me the model. I will include one by one when you say. Everyone has chance to say. No problem. If you can look at the ANOVA table. You can look at the ANOVA table. Yes. Anyone? If you don't say anything, I will keep it as it is. No problem. This is the last topic I want to discuss with you. Not much, last topic. So if you keep, I will also keep as it is. No problem. So you'll have to tell the components. Doesn't matter whether it is strong or not.
Block.
Pardon?
Effect of block.
Right. So first is block. Right. Okay. What
Then
is that?
factor irrigation.
Irrigation. Right. Which is the main factor here? Main
Irrigation.
block. Oh yes, irrigation. So that I will write it as irrigation. Then what is the third one?
Interaction between irrigation
Irrigation and
block.
excellent. Good. So I'll put it as block into irrigation. So this is actually going to function as what? Interaction between irrigation and block going to function as what?
Error rate.
Error ray. Right. Okay. So keep that in mind. What is next?
Nitrogen effect.
Then irrigation into nitrogen. Then Then what? Normal error term, so that we don't need to include that. That is the error B, right? We don't need to include that. That is all. That's all. In this case. In this case, this is all. Then run simply. Right? Once you run it, right? Have you all taken down this? Kalian முடிஞ்சா சொல்லுங்க. Lihat warna kia. Yeah.
Okay, sir.
Okay. Right. We will submit the program. As usual, the first step, the whole information is coming up. Here the information is coming up. Irrigation level, 2 levels. Nitrogen, 3 levels. Block, 3 blocks. Total observation is 18. So look at the model. Model is significant, but model consists of several information, so that we cannot simply say, since the model is significant, everything is significant. No, we cannot. So model, you see, it is giving with so many components. Block, treatment, irrigation, sorry, block irrigation, irrigation into block, nitrogen, and the last one, irrigation into nitrogen. You see here, all calculated value here has been divided by this error term. All calculated value has been divided by the normal error term. For us, we'll have to change some of this. What is that? Which calculated value will have to divide by a different component? Can you tell me in our split plot design? Look at the example. Actually, this block and irrigation, if you want to test block or if you want to test irrigation, the error term is what? Normally we don't test block, but the error term is irrigation into block. So that here, especially the irrigation, this is the others are okay. Nitrogen, irrigation into nitrogen. So that is also significant, no problem. Here in this split plot, not like in factorial, if the interaction is significant, we take that also into consideration. If the nitrogen and also into significant, we consider that also into consideration, right? Because it is a large plot, small plot differences. Okay, right. So here, to test our irrigation, this is not the F value. To test that F value, this is my mean square. 239.8. This is to test the irrigation. Numerator is 239.8. The denominator is 21.45. So this is my denominator. This is the error term for testing irrigation. So this is, you will get roughly 11 point something. That's the answer. You can do it manually, or you can ask the computer to calculate. So I'm going to ask the computer to calculate, similar to earlier one. Test, anyone? How to write test? Peony? Arosha? Hypothesis, irrigation, hypothesis, irrigation, error term. What is the error term? Irrigation into irrigation into block. We can write irrigation into block or block into irrigation. It will get the same answer. Don't worry about that. Okay. Right. Now we can test. We can run this. So everything is same. We will go to the last box. We go to the last box. This is where we test our irrigation. You see irrigation. Our value is, as I said, 11.18. So it is 239 point something divided by, what is the value? 21.45. So that is the value. Right? But still it is significant. Not significant, right? 0. What is the value? 0.07. So here we can say irrigation. Is it significant? Anyone? Look at earlier. Earlier it was divided by?
No.
Yeah, earlier it was divided by the normal error, error B. So it shows significant, right? Now look at this value. Is it significant now? If we take alpha as 0.05, now it is not significant because alpha value is higher. Sorry, alpha value is smaller than the probability value. So irrigation is not significant. What about the second one? Nitrogen. Whether nitrogen is significant or not. Look at the nitrogen here. Nitrogen, okay, that is significant. I'll put it as significant. Then irrigation into nitrogen, whether that is significant. That is also significant. You see, this is the story in this split plot design. Then again, the mean separation is same as the factorial concept. Mean separation is same as factorial concept. For each irrigation, we separate or which nitrogen is better. For each nitrogen, which irrigation is better. So either way is possible. Either you'll have to keep the nitrogen level constant, explaining the irrigation, or keep the irrigation levels constant and explain the nitrogen levels. Both ways are possible. Okay. Right. So that's all I would like to give you using SAS. Maybe I will give you one more command or thing. Let's say you see, I have, for example, we can enter, this is yield. This is, for example, dry matter. I will put it as dry matter, leaf area. So we can enter all the data in one set. So we'll have to enter like this. Dry matter, some value, 4.8 something. Then the leaf area, 2.3 something. I don't know the values, but you see, we can enter all the parameters like this, right? After entering, because in one shot we can do the ANOVA for all. We don't want to enter the data separately. You enter the data in setup, right? And you will have to do the analysis. Here I simply say yield, dry matter, leaf area. So it will give 3 different ANOVA for 3 different parameters: yield, dry matter, and the what do you call leaf area. So I will just put an example, right? Block. I'll take a simple example because these are more complicated. I will have some value, right? 5.36, 4.2. Just example, huh? I don't know what are the actual value. Can have some values. I'm just playing with some data. You can enter different data. Are you all in?
Yes, sir.
Okay. If like it in the Sharon,
Yes, sir.
என்ன விளங்கி சொல்லுங்க.
இப்ப சார் இப்ப இந்த ஈல்டு வந்து இப்ப வேற காம்போனன்ட்ஸுக்கும் ட்ரை மேட்டர் ஒரே நேரத்துல என்னண்டு அந்த பை வந்து கணக்க வையல அதுக்கு ஏத்த மாதிரி என்னண்டு எல்லாத்துக்கும் ஒரே நேரத்துல அனோவா எடுக்கும்.
ஒரே அனோவா ஒரே செட்டப்ல எடுக்கலாம். Because you can enter the data in the Excel sheet at once. You can bring it here. Then you can get the ANOVA because you can go single by single or you can do it at one shot. I'm just showing how it could be, right? So I'm just showing an example. Right, some playing with some data. Don't worry about this, playing with some data. Now I have put, I'm just removing this, right? Testing, we can do it later. So just I want to say, if you, in one shot, we can do it several ANOVAs. Right? You can enter any data and run it. You see, I will run it and see. This is for the yield. First one is for the yield. Right? Second one is for the LA. Something is missing. Dry matter. Dry matter also coming. Yes. So this is for dry matter. Earlier one. This is for what? This ANOVA for yield. right? Look at the second ANOVA. That is for dry matter. Okay. Same thing. The third ANOVA for leaf area. I put LA, leaf area. You see? So in one shot, you can do the ANOVA for everything. You don't need to do it one by one. In one shot, you can do it. So what did I do here? Right? Normally, let's say you are in soil science. You are measuring in the soil samples. You are measuring nitrogen. You are measuring phosphorus. You are measuring potassium. From the same sample, you are measuring, let's say, magnesium or whatever it is. You can enter in everything in each column. Then you can do that same set of analysis in one shot. Everything is coming. You don't need to say, because here, look at here. If I say yield equal the rest of the information, it will give the ANOVA for yield. Then if I say dry matter equal block irrigation and so on, then it will give the only the ANOVA for dry matter. Similarly, if I say leaf area is equal blah blah blah, then it will give the ANOVA for leaf area. But in one shot, you can get it if you type yield, dry matter, leaf area. So it will take one ANOVA at a time, relating yield with the other component, leaf area with other component, and the dry matter with other component. So that is also possible. You don't need to enter the data at different times. And the other thing, sometimes you see, I have here all the data. I have how many data? About the irrigation, about the nitrogen, about the block, about the yield, about the dry matter, about the leaf area. Now, after putting the input, so many variables, we don't need to include all the variables here. So now you see, I can keep the other variable as it is. I am simply running this program with only leaf area, LA, you see. Now I am going to run. No harm with, sorry, something went wrong maybe. Normally, no harm with LA. Did I do anything wrong? Something wrong. LA, yield. Let's run. Yeah, that is coming. Yield is coming. So likewise, when you do it for yield, it is giving the answer for only yield, or the ANOVA for only yield. It will not harm anything with the other dry matter or leaf area, right? When I said LA, why it is not accepting? Something wrong. LA is equal block. Now it is, maybe I have typed something else. So now you see, this is for LA, right? This is for leaf area. So likewise, you can do it individually. So nothing will happen. No harm to keep the data as it is. Similarly, one more thing I want to say. Let's say I have normally in agronomy or any other crops, you have several harvests. You have several harvests. How many pickings? For example, chili. How many pickings you go with? 1 picking, 2 picking, 3 picking? Anyone? I will consider in chili, I have 3 pickings. That means in 5 days, go and pick for the second round. Tanish Kumar, do you understand what is picking?
Yes, sir.
Right. So 3 picks. So we can enter the data in 3 picks. We can do the analysis. Now, if I want to add all these picks, I say simply y is equal y1 plus y2 plus y3. Got it? Y1 plus y2. Then in the analysis, if I want to do the effect after combining everything, I simply say y. Do you understand? So all these pickings, I mean, in crops, this is one example. We can add the pickings. So we don't want to keep calculating what is the total picking. If you calculate the total picking, then if I want to say which picking is higher to see the difference between the picking, first picking or second picking, third picking. As an example, normally first picking you get the more yield. So then we can test that also as an example. So that we want to enter the data separate. If you enter all the data together, what will happen? You cannot separate it, isn't it? Do you understand? If you simply enter after adding all the data, can you separate what is y1, what is y2, what is y3? No, we cannot separate. Now, if you enter separately y1,
We
y2,
could not
y3.
hear you, sir, clearly.
Huh? Yeah, maybe some reconnect. Yeah, we will wait. Yeah, something went wrong. Can you all hear me now? Can you all hear me? Hello? Yes, Kumar? Hello? Can you hear me now?
Yes, sir. Now we can hear.
Okay, right. What is highlighted here is mainly, suppose if you have 3 pluckings or 4 pluckings, if you add all the pluckings together at the beginning, then we cannot separate and see the effects. If in case if I want to see the real effects of different plucking, then I cannot include that at the later stage. If you add everything, but if you enter the data separately, y1, y2, y3, then at any time I can add, and any time I can separate. For example, I just did this. I'm going to run this and see. You see now the results is giving for y, not for yield. Y, where it is added all the y1, y2, y3 as an example. Don't worry about this 3 yield, y1, y2, y3 as an example. So it is giving some results with y. So this y is actually combination of these 3. Isn't it? If I want to do the analysis only y3, yes. y2, yes. y1, yes. So that is the advantage in SAS. You can add and play around with the values very easy. Right, any questions? I want to stop with this, any questions? So that is enough for you all to get to know. Any questions? Any questions? Can you all hear me?
Yes, sir.
Any question? ஏதாவது கேள்விகள் முன்னாடி பிரச்சனை தீரணும் ஏதாவது கேள்விகள் இருக்குன்னா கேளுங்க. Yes. No one has questions, huh? Even from theory or practical, whatever it is. Any question? Because since today is the last class, so any questions from any field, either practical or theory or whatever it is. Yeah. Any questions? Right. If there's no questions, I think we can wind up. All right. Anything to be said? So again, problem with the connection.
Sir,
Yeah, some connection problem. Yes. Yes.
sir,
Yes. I can hear.
sir, I could not hear. Sir, is it audible?
Yeah. I can hear you. I can hear.
So one student asked, sir, did you give that recordings?
Which student? Who is that?
So do I need to tell her or his name?
Pardon?
Okay.
Who is that?
Indu Jalani asks, sir.
Okay. Recording I cannot give directly because I don't know, because we have to upload and it's a long work. But I will talk to who is that Vern sir, and see how we can do it. Vern sir has my previous reports. I don't know whether it will be worth. I will check with Vern sir and let you know. Right?
Okay, sir.
Okay. Who else asked?
I also, sir.
You also. Who else? Only two.
Others, please, if you want, you also raise, tell to sir.
Yeah. Right. Because last time I think SAS I told it to them, but not up to this extent. I'm not sure. So that yes, I can